Good morning. I am Dr. SENTHILKUMAR, working as Assistant Professor Deputy Coordinator, Mathematics Wing, DDE, Annamalai University, Chidambaram. For B.SC Mathematics first year and first semester, we are going to see calculus. In calculus, there are 5 units. We are going to see the 5th unit, beta and gamma function. Gamma function, we are defining gamma function, gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 into dx. Here n greater than 0. We are defining gamma function gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 dx. Here n greater than 0. Now we are going to prove that gamma n plus 1 equal to n into gamma n. We are going to prove that gamma n plus 1 equal to n into gamma n. We know that gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 into dx. Put n equal to n plus 1. So, gamma n plus 1 equal to integral 0 to infinity e power minus x, x power n plus 1 minus 1 into dx. Okay. This is integral 0 to infinity e power minus x, x power n dx. Now, we are going to write this one. Take u equal to x power n, du equal to nx power n minus 1 into dx, and taking dv equal to e power minus x dx, integrating we get v equal to e minus e power minus x. Now, we are using the formula in the u dv equal to integral u dv equal to uv minus integral v du, using by uv minus e power minus x, x power n, integral 0 to infinity minus integral 0 to infinity v du minus e power minus x into nx power n minus 1 dx. Equal minus x power n e power minus x 0 to infinity minus or minus plus n into 0 to infinity e power minus x, x power n minus 1 dx. Here putting upper limit for x infinity power n e power minus infinity minus lower limit 0 power n e power minus 0 plus n into 0 to infinity e power minus x, x power n minus 1 dx. So, infinity here e power infinity 0, here 0. So, both of becomes vanish, that is equal to integral, so n into integral 0 to infinity e power minus x, x power n minus 1 into dx. This is nothing but gamma n. So, now we have proved gamma n plus 1 equal to n into gamma n. Now, we have see gamma 1 by dimension gamma 1 equal to integral 0 to infinity e power minus x, x power 1 minus 1 dx, integral 0 to infinity e power minus x, anything about 0 1, that is dx, integrating e power minus x minus e power minus x 0 to infinity, taking minus outside e power minus infinity minus e power 0, e power infinity 0, e power 0 1, this is equal to 1. So, gamma 1 equal to 1. Now, recurrence relation for gamma function, gamma n plus 1 equal to n factorial. Recurrence relation for gamma function is gamma n plus 1 equal to n factorial. Now, we are going to prove that. We know that gamma n plus 1 equal to n into gamma n. Okay. We know just to prove that gamma n plus 1 equal to n into gamma n. In this way, we can write gamma n equal to n minus 1 into gamma n minus 1. Similarly, gamma n minus 1 we can write as gamma n minus 2 into gamma n minus 2. Proceeding this way, n into n minus 1, n minus 2 and so on, the last term will be n minus 1 into gamma n minus 1. N into n minus 1, n minus 2 and so on, n minus 1 becomes 1 and gamma 1, that is n into n minus 1 n minus 2, n minus 3 and so on, 3 to 1. This is nothing but n factorial. So the reconciliation for gamma function is gamma n plus 1 gamma n plus 1 equal to n factorial. This reconciliation is for only when n greater than 0, otherwise it is not possible. Okay. Now we know that gamma n plus 1 equal to n into gamma n. From this we can write gamma n equal to gamma n plus 1 by n. What about gamma 0? Gamma 0 equal to gamma 0 plus 1 by 0, gamma 1 by 0 equals infinity. So gamma 0 is infinity. What about gamma minus 1? Using this formula, gamma minus 1 plus 1 by minus 1, gamma minus 1 plus 1, gamma 0 by minus 1, we know that gamma 0 is infinity. So in general, gamma n is undefined when n equal to 0, minus 1, minus 2, minus 3 and so on. So gamma function is undefined when n equals 0, minus 1, minus 2, minus 3 for negative integer. Whereas for negative fraction there is a gamma function. Let's wait and see. Now find the value of gamma 7 by 2, gamma minus 5 by 2. Okay. We know that gamma n plus 1 equal to n into gamma n. Now we are going to find gamma 7 by 2, and this can be written as gamma 5 by 2 plus 1. So using this formula, gamma n plus 1 equal to n into gamma n, 5 by 2 into 5 by 2. Again this can be written as 5 by 2 into gamma 5 by 2 can be written as gamma 3 by 2 plus 1. Now using this formula, gamma n plus 1 equal to n into gamma n equal to 5 by 2 can be written as 5 by 2 into 3 by 2 gamma 3 by 2. Again 5 by 2, 3 by 2, gamma 3 by 2 written as 1 by 2 plus 1. Okay. This is 15 by 4 into gamma 1 by 2 plus 1. Again gamma n plus 1 into n into gamma n 1 by 2 into gamma 1 by 2. This is 15 by 8 gamma 1 by 2, 15 by 8 into root pi. So gamma 1 by 2 equal to root pi, we have to prove later. We know that gamma n plus 1 equal to n into gamma n implies gamma n equal to gamma n plus 1 by n. So when the n is negative fraction, we will write using this formula. Gamma minus 5 by 2 equal to gamma minus 5 by 2 plus 1 by minus 5 by 2 using this formula. This becomes was gamma minus 3 by 2 by minus 5 by 2. Again using the formula, this can be written as gamma minus 3 by 2 plus 1 by minus 5 by 2 into minus 3 by 2. This is gamma minus 1 by 2 by 15 by 8. Again using the formula, gamma minus 1 by 2 plus 1 by 15 by 8 into minus 1 by 2. This is gamma 1 by 2 by minus, this is 15 by 4, 15 by 8, that is minus 8 by 15 into root pi. We know gamma 1 by 2 equal to root pi, we have to prove later. Now we are to prove gamma 1 by 2 equal to root pi. We know that gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 into dx. Put n equal to 1 by 2, integral 0 to infinity e power minus x, x power 1 by 2 minus 1 dx. This is equal to integral 0 to infinity e power minus x, x power minus of dx. Now put x equal to s square. I am going to put x equal to s square. So dx becomes 2s ds. Okay. Here limit x power 0 to infinity. I am putting x equal to s square when x equal to 0. When x equal to 0, s also 0. When x equal to infinity, s also infinity. So the integral becomes integral 0 to infinity e power minus x square, so minus s square into s square whole power minus of dx 2s ds. Okay. This becomes, this 2 cancel, this s power minus 1 and this s will cancel. So now we are getting equal twice integral 0 to infinity e power minus s square ds. This is equal to twice integral 0 to infinity e power minus x square dx, since s is dummy. So what we are getting, put x equal to s square, we get a result. Now this is gamma 1 by 2. Squaring on both sides, gamma 1 by 2 whole square, instead of squaring this side, I am taking two variable like this, twice integral 0 to infinity e power minus x square into dx into twice integral 0 to infinity e power minus y square dy. This becomes 4 integral 0 to infinity e power minus of x square plus y square dx dy. We cannot integrate directly this integration. So by changing the double integral into polar coordinates, put x equal to r cos theta, y equal to r sin theta. By changing the double integral to polar coordinates, put x equal to r cos theta, y equal to r sin theta, then the elemental area dx dy becomes r dr d theta. We can study in the lower classes. Okay. By changing the double integral polar coordinates, put x equal to r cos theta, y equal to r sin theta, then the elemental area dx dy becomes r dr d theta. So our integral area is in the first quadrant. So in the first quadrant, this is r, this is theta. So what is limits for r? So r varies from 0 to infinity. R varies from 0 to infinity. R varies from 0 to infinity. What is the limit for theta in the first quadrant? 0 to 90, 5 by 2. That is theta varies from 0 to 5 by 2. What about x square plus y square? X square equal to r square cos square theta, y square equal to r square sin square theta. So the x square plus y square equal to, taking r square outside, r square into sin square theta plus cos square theta equal to 1. Therefore x square plus y square equal to r square. So now the integral becomes 4 integral 0 to 5 by 2 integral 0 to infinity e power minus r square r dr d theta. Now we are going to integrate the inner part of the integral. So integral 0 to infinity e power minus r square e into r dr. Put r square equal to t, 2r dr equal to dt. Now here r dr equal to dt by 2. So when r equal to 0, t also 0. When r equal to infinity, t also infinity. So there is no change in limit. So this integral becomes integral 0 to infinity e power minus r square t r dr dt by 2. So 1 by 2 dt. So 1 by 2 e power minus t minus e power minus t 0 to infinity. So when putting upper limit e power infinity 0 and lower limit becomes 1. So this becomes minus 1 by 2 e power infinity minus e power 0. So e power 0, e power 0 1 minus a minus plus 1 by 2. So the integral value is 1 by 2. So this becomes twice integral 0 to pi by 2 d theta. Twice integral d theta, theta 0 to pi by 2. Putting upper limit for theta pi by 2 minus lower limit for 0 theta 0. That is 2 into pi by 2, 2 will cancel, it becomes pi. The left hand side, gamma 1 by 2 whole square equal to pi implies gamma 1 by 2 equal to root pi. So here always gamma 1 by 2 equal to root pi. Now we can write another form of gamma function, gamma n equal to integral 0 to infinity e power minus x square x power 2n minus 1 into dx. We can write gamma function in another form of gamma function, this one. For proof, we know that gamma n equal to integral 0 to infinity e power minus x x power n minus 1 into dx. I put x equal to y square, x equal to y square. So dx becomes 2y dy. When x equal to 0, y also 0. When x equal to infinity, y also infinity. Therefore, the integral becomes, send here, put x equal to y square and dx equal to 2y dy. That is equal to integral 0 to infinity e power minus y square whole power n minus 1 dx becomes 2y dy. That is twice integral 0 to infinity e power minus y square y power 2n minus 2 into y power 1, that is y power 2n minus 1 dy. So twice integral 0 to infinity e power minus y square y power 2n minus 1 dy. Since y is dummy, we can write twice integral 0 to infinity e power minus x square x power 2n minus 1 into dy. So this is another form of gamma function. Okay. Now we have defined gamma function and the recurrent solution for gamma function and find the value of some gamma function and prove that gamma 1 by 2 equal to root pi. Next we are going to see beta function. So before we are going to see beta function, we are going to evaluate some problem. Evaluate integral 0 to infinity e power minus x square dx. Evaluate integral 0 to infinity e power minus x square dx. Solution. Put x square equal to t. So this integral becomes 2x dx equal to dt. Okay. Implies x equal to root t. So dx equal to dt by 2x, that is dt by 2 root t. Okay. When x equal to 0, t also 0. When x equal to infinity, t also infinity. So there is no change in limit. So put x square equal to t implies x equal to root t, 2x dx equal to dt, dx equal to dt by 2x, dt by 2 root t. So the integral becomes integral 0 to infinity e power minus t, x square equal to t, dx equal to dt by 2 root t. Okay. So this becomes 1 by 2 integral 0 to infinity e power minus t dt by t power of. This is equal to 1 by 2 integral 0 to infinity e power minus t, t power minus of dt. Okay. This is 1 by 2 integral 0 to infinity e power minus t, minus of can be written as e power t power 1 by 2 minus 1 dt. We know that gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 into dx. So comparing these two, here n equal to 1 by 2. So this is equal to 1 by 2 gamma 1 by 2. Just we get proof gamma 1 by 2 equal to root pi by 2. Next problem, we have to evaluate integral minus infinity plus infinity e power minus x square dx. Evaluate integral minus infinity plus infinity e power minus x square dx. We know that your function f of x is said to be even function. F of x is even function if f of minus x equal to f of x. F of x is said to be even function if f of minus x equal to f of x. For example, f of x equal to, f of x equal to cos x. F of x equal to cos x. So f of minus x equal to cos minus x, cos minus x equal to cos x. So f of minus x equal to f of x. So this function is even function. Now here when we take here e power minus x, taking f of x equal to x square, f of minus x equal to minus x whole square equal to x square equal to f of x. So this is even function. Therefore the given can be written as integral minus infinity plus infinity e power minus x square dx equal to twice integral 0 to infinity e power minus x square dx. We know that the properties of determinant integral minus a to plus a f of x dx equal to twice integral 0 to a f of x dx if f of x is an even function. Okay. Just we have find out the value in the 0 to e power minus what we find out value? Pi by root 2. So 2 into root pi by 2, this becomes root pi. Next problem, evaluate integral 0 to 1 x power m log 1 by x whole power n dx. Evaluate integral 0 to 1 x power m log 1 by x whole power n dx. Solution, I am taking y equal to log 1 by x. I am taking y equal to log 1 by x. Taking log exponential function log both sides, e power log 1 by x equal to e power y. We know that e power log x equal to x implies 1 by x equal to e power y. 1 by x equal to e power y implies x equal to e power minus y, implies x equal to e power minus y. Now, when x equal to 0, when x equal to 0, y equal to infinity. When x equal to 0, y equal to infinity. When x equal to 1, here we are given the limit for x equal to 0 to 1. When x equal to 1, y equal to 0. So, the integral becomes what? When x equal to 0, y equal to infinity. Okay. When x equal to 1, y becomes 0. Okay. Dx equal to minus e power minus y dy. So, the integral becomes integral infinity to 0 e power minus y whole power m and y power n minus e power minus y dy. So, we know that the properties of definite integral a to b f of x dx equal to minus integral b to a f of x dx. So, for removing the minus sign or cancel minus sign, this integral becomes integral 0 to infinity e power minus ym into y power n e power minus y dy. Integral 0 to infinity e power, taking minus side m plus 1 into y power n dy. So, this integral becomes 0 to infinity minus I m plus 1 to y power n dy. Put m plus 1 into y equal to t, m plus 1 into d. Here limit for y 0 to infinity. When y equal to 0, y or t also 0. When y equal to infinity, t also infinity. So, m dy equal to dt, dy equal to dt by m. Sorry, m plus 1 dy equal to dt implies dy equal to dt by m plus 1. So the result becomes implies y equal to t by m plus 1. Okay. So this integral becomes integral 0 to infinity e power minus t y t by m plus 1 and dy becomes dt power n. Y becomes t power, this becomes power n by m plus 1. So in the m plus 1 whole power n, here m plus 1, so 1 by m plus 1 whole power n plus 1 into 0 to infinity e power minus t power n dt. We know that this becomes one by m plus 1 whole power n plus 1 into gamma n plus 1. So the integral becomes gamma n plus 1 by m plus 1 whole power n plus 1.